Jai Hind students, welcome to my YouTube channel. In this session students, we will be discussing some more numericals based on subtraction of vectors. Yes, subtraction of vectors. But before we start this session, I must advise you to add wings to your imagination. That is, students, never hesitate to fly high. What I mean to say is that always try to dream big, have vision, have big dreams. But I am warning you against any sort of daydreaming. Dream big, but you need to put in proportionate and concentrated and dedicated effort to realize those big dreams. Right? So you all are capable and you can do whatever you feel like. The only thing is trust your abilities. Right? So with that, let's begin this session. And as I told you, we will be discussing these 5 questions which are related to relative motion, that is relative velocity, and we will do these questions using subtraction of vectors. How the vectors are subtracted. Right? So that we will discuss. So let's start with the first question. First question is, to a man going east in a car with a velocity of 40 km per hour, a train appears to move towards north. With a velocity of 40√3 km per hour. What is the actual velocity and direction of motion of the train? Right? So let us try to represent it diagrammatically. Students, look, these are the questions in which you need to draw the appropriate diagrams. Right? It is absolutely mandatory to draw the diagrams. Without diagrams, we can't solve these questions, right? So, let's draw the appropriate diagram now. So, these are the north, south, west, east direction, right? Now, as per the question, the man is going east in a car. This is the car and its speed is given to be 40 km per hour. Right, students? A train appears to move towards north. This is the train. It is actually the relative velocity of the train with respect to the car. Right? It is actually the relative velocity of the train with respect to the car. Both the car and the train are moving. So, as per the person who is in the car, the train appears to be moving towards north. So this is the relative velocity of the train with respect to the passenger or the driver in the car. So it is actually the relative velocity of train with respect to car which is given, and it is given to be, its magnitude is given to be 40√3 km per hour. This is given. Now we are supposed to find what is the actual velocity and direction of the motion of the train. Vt is to be found. And obviously its magnitude as well as direction, right? Now students, we are aware how to represent relative velocity of one object with respect to other in vector form. How to represent? Now we are aware relative velocity of train with respect to car. It is given by velocity of train minus velocity of car in the vector form. Isn't it, students? Now this is the VTC, is the subtraction of VT vector and VC vector. We have not done subtraction of vectors, but it can be converted into addition. What we can write over here is VTC, it may be written as VT vector plus minus VC vector. So what I mean to say is that the same statement can be understood as the vector addition of velocity of train and the negative of the velocity of car. Again repeat, VTC, which is the relative velocity of the train with respect to car, is actually the vector addition of the velocity of the train and the negative of the velocity of the car. Now minus VC. In order to evaluate it and represent diagrammatically, what we need to do is VC is around this direction. So negative of VC would be around this direction. So draw minus VC. It will be like this. this will be minus VC. Is it clear, students? Now, VT and minus VC. VT would be somewhere over here because VTC is the resultant. VTC is the resultant of VT and minus C. Now you are aware, students, if these two are represented by the two adjacent sides of a parallelogram acting at a point, then its resultant would be given by the diagonal of the parallelogram passing through the same point. So this must represent the diagonal of the two adjacent sides of a parallelogram. One of its adjacent side is along this direction and the other should be somewhere along this direction, isn't it? So along this direction should be the velocity of the train, actual velocity of the train. So if you complete the diagram, it should be like this. Complete the parallelogram like this. Complete the parallelogram. So as I have told you, VTC, it is the resultant of VT vector and minus VC vector. VT vector and minus VC vector, these two represents the adjacent sides of a parallelogram acting at point 2. So the resultant is given by VTC, which is the diagonal of this parallelogram passing through the same point. Right? And you can verify this statement using triangle law of vector addition. Right? So what to do is, in a parallelogram, opposite sides are equal as well as parallel. So this is minus VC. So this would be also, draw the vector diagram. It is minus VC. Now consider this triangle. Consider this triangle. Now these are the two sides of the triangle taken in the same order. So VT vector plus minus VC vector. It should be equal to the closing or third side of the triangle taken in the opposite order. That is VT vector plus minus VC vector. It would be equal to VTC vector. So this mathematical statement should be in agreement with the diagram in which the triangle of vector addition must be applicable. So you can cross check it whether the diagram is correct or not. Clear, students? Okay. Now what we are supposed to do is, we are supposed to find out VT and its direction. Let's find out its magnitude first, right? So this is a right angled triangle, isn't it? I'll draw the diagram again. This is it. Let's consider the magnitude. The magnitude of this is 40. The magnitude of this side is 40 units, right? The magnitude of this is 40 root 3. So this is VT. This can be easily found. The magnitude of VC is 40 and the magnitude of VTC is 40 root 3. So it's a right angled triangle. By applying Pythagoras theorem, the magnitude of VT can be easily calculated. So the magnitude of VT would be equal to square root of VC square plus VTC square. So let's substitute the value. So what do you get? VC square, 40 square plus 40 root 3 square. So that will give us VT, it will be equal to square root of 1600 plus 40 square, 16 multiplied by 3, 4800. So that in turn will give us 0041 carry, 45, 6400. So which will give us 80 km per hour. So student, this is the answer of the first part. So the train, its actual speed is 80 km per hour. The train must be running with this speed. Now this is not the complete answer. We have found only the magnitude. Now we need to get the direction. Now look, suppose this is angle theta. Let us consider this to be angle theta, right? So this is where the train is moving. This is where the train is moving. We are aware of the dimensions of all these. So we can very much make use of trigonometric function, isn't it? So let's get sine theta. Sine theta, cos theta, tan theta, it's your wish to consider any trigonometric function. Sine is perpendicular by hypotenuse. Perpendicular, its dimension is 40. Hypotenuse, this is the hypotenuse, it is 80. So sine theta is equal to half or theta is equal to 30 degree. So This is the angle. Theta is equal to 30 degree. Now how to express the direction, students? So direction would be, direction is the train must be making an angle of 30 degree east of north. The train must be making an angle of 30 degree east of north. So this is how the direction is represented, right? So the actual velocity of the train is 80 km per hour in a direction making an angle of 30 degree east of north, right? In a direction making an angle of 30 degree east of north. So this is how the questions needs to be done. So the diagram is of utmost importance, right? So we are over with question number 1. Let's discuss question number 2. It's similar to that of the previous question. So let's try to solve it. Okay. Next question is, a train is moving due east and a car is moving due north, both with 30 km per hour. What is the observed speed and the direction of motion of the car to the passenger in the train? So here, what we are supposed to find is the relative velocity of the car with respect to the train, right? We are supposed to find out the speed and direction of motion of the car to the passenger in the train with respect to the passenger, and passenger is in the train. So here we need to find out the relative velocity of the car with respect to the train, right? So let's draw the diagram. Okay, second one. A train is moving east. Let's draw the appropriate diagram. This is north, this is south, this is west, and this is east. A train is moving due east along this direction with speed of 30 km per hour. And a car is moving due north. This is the direction of motion of the car. And its speed is also given to be, magnitude is given to be 30 km per hour. We are supposed to find out the speed and direction of motion of the car to the passenger in the train, right? So what we need to find is velocity, relative velocity of car with respect to the passenger in the train. So we are supposed to find out the relative velocity of car with respect to the train. So in the vector form you are aware it is Vc vector minus Vt vector. Now again, in order to find Vct, we must subtract Vt vector from Vc vector. So subtraction of vectors is involved. But we need to convert it into addition of vectors. So that can be done by writing it like this, plus minus Vt vector. So this same statement can be stated as the relative velocity of car with respect to train is given by the vector addition of Vc vector and negative of Vt vector. Negative of Vt vector, it is minus Vt vector. Clear, students? Okay. So in order to obtain this resultant, we need to get minus Vt vector. Vt vector is along this direction. So minus Vt vector would be in the opposite direction. It is like this, minus Vt. This is Vc vector. Both are of equal magnitude. So now Vct is the resultant of Vc vector and minus Vt vector. It is the resultant of these two. Clear, students? So these are the two adjacent sides of a parallelogram and its resultant will be given by the diagonal of the parallelogram. So this is the resultant. And here we are aware, no need to solve it mathematically. Whenever the two vectors are of equal magnitude, here the magnitude of both these vectors is equal, each being 30 km per hour, then the resultant always bisects the angle between them. So this angle would be 45 degree, right? This we need not to solve it, we can directly predict. Again I repeat, whenever the two vectors are of equal magnitude, then the resultant tends to bisect the angle between them, right? So you can complete the parallelogram like this. You can complete the parallelogram, right? So this is VCT vector. Again, as I have told you, this is minus Vt, this is a parallelogram, so opposite sides are equal. So this is also minus Vt vector So this is a triangle. Applying triangle law of vector addition, this statement should hold valid. Let's check it out. These are the two vectors representing the two sides of a triangle taken in the same order, like this. So it is VC vector minus VT vector. VC vector plus minus VT vector is equal to the third or closing side of the triangle taken in the opposite order. So these are in agreement. So our diagram is perfectly correct, isn't it? Okay, now regarding magnitude. Consider this triangle, right? It's a right angle triangle. This is 30, this is also 30. So these two being 90 degree, the resultant would be given by magnitude. Whenever the two vectors are perpendicular, then the resultant is given by square root of Vt square plus Vc square. So it will give us 30 square plus 30 square. So that will be 30 root 2 VCT. It will be equal to 30 root 2 kilometer per hour. Right? And what about the direction? Direction, as we have discussed earlier, it will be making an angle of 45 degree. It will bisect the angle between these two vectors, which is, in this case, will be 45 degree with north or with west. So that is basically northwest. So direction is northwest, making an angle of 45 degree with either north or west direction. Clear, students? So this is the complete answer, magnitude as well as the direction. Right? Okay, let's proceed to the next question then, third one. Again, it is based on the subtraction of vectors, but we will convert it into addition of vectors by introducing the concept of negative vector. Right? So, we are over with question 1, question 2. Let's concentrate on question 3. Again, it's a question based on direction. This is north, this is south, this is west, and this is east. A car traveling at 36 km per hour due north. Okay. A car is traveling along this direction, due north. Suppose it is V1, initial, and it is 36 km per hour. So if you convert it in meters per second, so kilometer per hour, it would be equal to 36 into 5 by 18 meter per second. So it will be equal to 10 meter per second. Right? So in SI it would be 10 meter per second. So it is 10 meter per second. Okay. Now it turns west in 5 seconds. It turns west like this. So this is final velocity. Again, its magnitude is 10 meter per second. It's given in the question. Maintains the same speed. What is the acceleration of the car and its direction? It's a very, very good question, students. Right? Now look, acceleration is given by time rate change in the velocity. Now in case of one dimension, when the body is moving along a straight path, then this formula is perfectly correct because all have the same direction, right? But here the direction of motion of the body changes. So we need to represent acceleration in the vector form in this case. So acceleration actually is represented as time rate change in the velocity of the body. And this is change in the velocity. Velocity is a vector quantity. Now in order to find acceleration we need to get this. So acceleration may be written as v2 vector plus minus v1 vector divided by t. So this is the formula to be used. Clear, students? So what to do? We need to find out the resultant of this, the magnitude of this. So change in velocity is v2 vector plus minus v1 vector. Now let's do it. Now look, v2 vector, it is along west. This is v2 vector. No doubt regarding this. Minus v1 vector. This is v1 vector. So minus v1 is negative of v1 vector. It will be along this direction. This is minus v1 vector. This is north, this is south, this is west, and this is east. Clear, students? Now v2 vector and minus v1 vector. Right? The vector addition of v2 vector and negative of v1 vector. Now what will be the resultant? It will be given by the diagonal like this. Complete the parallelogram. Okay. So this one will give the change in the velocity resultant. The change in the velocity, del V. Right? Which will be V2 minus V1, the magnitude of V2 minus V1. Okay. Now how to proceed like? How to proceed like? This is a parallelogram, so opposite sides are equal and parallel. So this is minus V1, so opposite side, this is also minus V1. Minus V1. So look again, I've always told you just to cross check it. Cross check your diagram with the triangle of vector addition. Right? And confirm it whether the diagram made by you is correct or not. So here in this triangle, apply triangle of vector addition. These are the two sides of the triangle taken in the same order. The vector result will be given by the closing side of the triangle taken in the opposite order. Isn't it? So V2 minus V1 is equal to del V. So the resultant is del V vector is equal to V2 vector minus V1 vector. So diagram is perfectly correct. Now this is in the vector form. What about its magnitude then? Change in velocity. What about its magnitude? Now this is the vector resultant of V2 vector and minus V1 vector which are inclined at a right angle. So whenever the two vectors are at right angle, then the magnitude of the resultant is given by square root of a square plus b square. If those two vectors happens to be a and b, right? Here it is V1 and V2. So it is V2 square plus minus V1 square. So it will give us 10 square plus 10 square. So it will be equal to 10 root 2. And it will be in meter per second. So students, what is the magnitude of the change in the velocity in this case? It is 10 root 2 meter per second. So acceleration in magnitude, it will be equal to change in velocity divided by time. What is change in velocity? 10 root 2 divided by what is the time taken for this change in velocity to take place? That time taken is given to be 5 seconds, right? So it is 5. So acceleration is 2 root 2 meter per second square. This is magnitude. This is not the complete answer. You need to represent the direction of the acceleration as well, right? So what about the direction of the acceleration? Acceleration is always along the direction of change in the velocity. So where is the change in the velocity? Along this direction. These two are in equal magnitude. Therefore, the resultant will bisect the angle between them. So this angle must be 45 degrees. So west-south. So this will be west-south. That is, the direction of the acceleration must be making an angle of 45 degrees with either west or south. So the direction is west-south. That is, magnitude of the acceleration is 2 root 2 west-south. That is making an angle of 45 degrees with either west or south direction. So this is how the questions needs to be done. Clear students? It's not one-dimensional case. It is the two-dimensional case where the direction of motion of the body gets changed. So here you need to solve acceleration vectorially, making use of laws of vector addition. Clear? Okay. Let's concentrate on the fourth question. It's a very, very interesting question. A policeman moving on a road with speed of 30 km per hour fires a bullet. Okay. Policeman, velocity of the policeman, it is given to be 30 km per hour. Let's convert it in SI. So it will be equal to 150 by 18. So that would be equal to I think 3. So 53 divided by 6 or 25 by 3 meter per second. So this is the velocity of the policeman. Right? It is the velocity of the policeman. Now, it fires a bullet at a thief's car moving with 192 km per hour. It is but obvious thief's car is moving at a greater speed as compared to that of police car. No doubt. Anyway, so thief's car, its velocity is 192 km per hour. Again, let's change it in SI. 5 by 18. So what to do is 6 3 18, 1 2 6 2 3. So 160 divided by 3 meter per second. Clear, students? So velocity of the thief's car is 160 by 3 meter per second. In the same direction, if the speed of the bullet is given to be 150 meter per second. With what speed does the bullet hit the thief's car? Situation is like this. This is thief's car. This is police car, and this is also moving along the same direction. And from the moving car of the police, a bullet is fired along this direction. Now look, bullet is fired from the police van, which is itself moving. So it is the case of dependent bodies. So what will be the effective speed of the bullet? Both are moving in the same direction. So the effective speed of the bullet is, now look, police van, it is moving along this direction, and along the same direction bullet is fired. So obviously the velocity of the bullet will get aided. So effective velocity of the bullet would be equal to, in this case, 150 plus velocity of the police van, which is 25 by 3. So it will be 475 divided by 3. Clear, students? In meter per second. This is the effective velocity of the bullet. It can be written as VB dash. It is the effective velocity of the bullet. Now here it is the case of dependent bodies. The velocity of the bullet does depend upon the velocity of the police van. Right? In case bullet was fired in a direction opposite to which the police van is moving, then the effective velocity of the bullet would have got reduced. But in this case, since police van and the bullet, both are, the bullet is fired along the same direction as that of the police van. Therefore, the net effective velocity of the bullet will get added up. So this is the situation. It is the case of dependent bodies. Now, this is the effective speed of bullet, isn't it? Now, thief's car, it is moving with this velocity, 160 by 3 meter per second. Now, as per the question, we are supposed to find out the speed with which the bullet hit the thief's car. Now, this is the effective velocity of the bullet. Now, we are supposed to find out the relative velocity of the bullet with respect to the thief's car. Both are independent bodies. Both are in motion. So, bullet will obviously strike the thief's car. So, both are in motion and in the same direction. So, as a result, the relative velocity of bullet with respect to thief's car, it would be equal to VB dash minus VT. Why minus? Because both these independent bodies are moving in the same direction. Clear? In this case, it was the dependent bodies. So, in the same direction, the speed get added up. In case of independent bodies, if they are moving in the same direction, then the relative velocity of one body with respect to the other would be given by the difference in the velocities of the two individual bodies. Right? So the velocity with which the bullet hits the thief's car would be VB dash minus VT. What is effective velocity of the bullet? It is 475 divided by 3. What is the velocity of the thief's car? It is 160 divided by 3. So let's solve it. So it is 105 and SI unit is meter per second. So students, it is with 105 meter per second. It is the velocity of the bullet with which it will strike the thief's car. This is actually the relative velocity of the bullet with respect to the thief's car. Right? Okay students, now question number 5. Rain is falling vertically with a speed of 25 meter per second. A cyclist is going at a speed of 10 meter per second in the direction from north to south. What is the apparent speed and the direction of the rain? So here we are supposed to find out the relative velocity of the rain with respect to the cyclist. Isn't it? So let's draw the diagram. And here again, rain is falling vertically downward. So as to represent it diagrammatically, we need to make use of three-dimensional diagram, isn't it? So this will be the proper diagram. This is suppose north, this is south, and this is west, and this is east. All are mutually perpendicular to each other, isn't it? All the directions, they are in the horizontal plane. So, this may be considered to be the vertical. This may be considered to be the vertical. Right, students? Now let's represent the vectors. Rain is falling vertically with a speed of 25 meters per second. So, this is the velocity of the rain. So, this is VR. It is given to be 25 meters per second. Right? Suppose this is point 2. This cyclist is going at a speed of 10 meters per second in the north to south direction. North to south. So, cyclist is moving from north to south. This is the velocity of the cyclist. It is 10 meters per second. Now look, students, both are in motion, rain as well as the cyclist. We need to find out the velocity of rain with respect to the cyclist. So it is the case of the relative motion when both are in motion. So the relative velocity of rain with respect to the cyclist in the vector form is VR vector minus VC vector. Isn't it? So it is the subtraction of these two vectors. But it can be rearranged in this particular manner. VRC vector, it may be written as VR vector plus minus VC vector. So it may be stated in this manner. The relative velocity of rain with respect to the cyclist is equal to the vector sum of VR vector and negative of VC vector. Clear? So this is the vector representation. So in order to get VRC, we need to get this resultant. Isn't it? Let's draw the vector diagram. So this is VR vector. What about minus VC vector? VC vector is from north to south. So minus VC vector would be from south to north. This is a negative of VC vector having equal magnitude but opposite directed. So this is minus VC vector. So now these are the two adjacent sides of a parallelogram, VR vector and minus VC vector. So complete the parallelogram. This is how the parallelogram is completed. Opposite sides, remember, they are equal, so having the same direction and same magnitude. So if this is of 10 magnitude, 10 units, it should be also of 10 units, isn't it? This is VC in magnitude. And this is of 25, so this will be also 25 meters per second in magnitude. Okay. So the vector resultant would be given by the diagonal of the parallelogram passing through the same point. So this must be VRC. So VR and minus VC. VR and minus VC. These are the two adjacent sides of a parallelogram acting at point O. The vector resultant as per parallelogram law of vector addition is given by the diagonal of this parallelogram passing through the same point. And the diagonal is VRC vector, which is the resultant of VR vector and minus VC vector. Clear? Again, as I told you to cross check whether the diagram drawn by you is correct or not. So this is a triangle. You can make use of triangle of vector addition. So these are the two sides of a triangle taken in the same order. Minus VC vector plus VR vector. Right? Minus VC vector plus VR vector. And the resultant is given by the closing side of the triangle taken in the opposite order, which is VRC. So it satisfies the triangle of vector addition. So the diagram is perfect. Right? Okay, let's proceed further. Now let's find out the magnitude and then we will get the direction. VRC, it is the result of these two perpendicular vectors. It's in the horizontal plane and this is vertical downward. So angle between these two is 90 degrees. So whenever the two vectors are inclined at right angle, then the magnitude of the resultant is given by square root of a square plus b square. If the two vectors happens to be a and b. So magnitude VRC, it would be given by square root of VR square plus minus VC square. So what you get is VR, that is 25, VC, it is magnitude is 10, so we get 625 plus 100. So it will be equal to square root of 725. Now look, make use of your common sense. Square of 27, it's 729, isn't it? So it is somewhat less than 27. So it can be written as 26.9 approximately meter per second. So the effective or the apparent speed of the rain is about 27 meter per second. To be precise, it is about 26.92 meter per second. This is the speed of the rain with respect to the cyclist, right? Now let's get its direction. Students, suppose this is the direction theta. This is the direction which the rain makes with the vertical. Now this is a right angled triangle, isn't it? This is a right angled triangle. So if we consider, let's consider sine theta. It will be equal to sine theta, it will be equal to perpendicular by hypotenuse. The dimension of this is 10, right? Divided by hypotenuse. This is base, this is perpendicular, and this is hypotenuse. Hypotenuse is of magnitude 25. So what do you get? 2 by 5, it is 0.4. So theta would be equal to sine inverse 0.4. Right? Theta is the angle which the rain makes with the vertical towards south. This would be the direction, towards south. So it is the angle with vertical towards south. So this is the complete answer. This is the magnitude and this is the direction. Clear, students? So I hope you now should feel confident solving these questions. We have done enough of questions in the previous 2-3 lectures. Also, we have discussed lots and lots of numericals based on triangle law, parabola law, vector addition, subtraction of vectors, relative motion, relative velocity, and then resolution of vectors. Right? So students, do practice more and more numericals. Right? That is how you can build up your confidence. Clear? So that's it for this particular session. Do join me in my next lecture. Right? Thank you so much and do take very good care of yourself. Remain blessed. Thank you.